So far, all of our examples have been really very straightforward, right? But we know that that's really not how life is. Life is never very straightforward. So what we're going to do is we're going to do it more complicated, okay? And then when we do this more complicated, we're going to show you how this functional notation can happen, right? You don't just have to use one alone. You can use them in conjunction with other things. You can do an A times a P given A plus an F times a P given F. And you might say, like, well, why would I do that? Well, if you had a cash flow, think of the cash flow that would look like that. You don't know what P is, but you know that you have this A out here for some period. And you know that you have an F out here. Okay? So how do I know what P is? Well, I've got to bring F back by itself, and I got to bring A back by itself. Okay? Now, remember, moving this money around, saying that some future value is worth a present value times P given F, that's all based on equivalence, right? We are indifferent as to whether we have the money now or some money in the future. We're indifferent. Because if I don't have this assurance of money in the future, I'll take my money right now and go put it somewhere else and earn interest. So we're indifferent. And when we're indifferent, we can also look at it is that the money that we put into something has to equal the money that we take out at a time. So I can't add $100 in year 0 and $100 in 10 years out and have $200, right? Because of interest. So what I have to do is I have to move the P back, the F back, and that's exactly what we've been doing. So equivalence, another way to think about it, is the money in equals the money out at a certain point in time, because you're guaranteed this interest rate. So let's do this example here, and I think this is going to help you make sense. So Sam wants to have $20,000 in 10 years. He knows he's going to get a small inheritance in 5 years of $5,000. I don't know how, but he knows. What should his monthly uniform payments be in an account that earns 3% compounded monthly? Well, let's write down our interpretation here. All right. So we know that the interest is 3% compounded monthly. So that would be 3% divided by 12 equals 0.25% per month. N is going to be 10 years times 12 months per year, so it's 120 months. All right, so we got that set up. Here's your 0, here's your 1, here's your period 120, okay? He needs, at the end of all of this, he needs $20,000. He doesn't know how much he's got to put into his little account here. But he does know that at year 5 equals period 60, right? 5 times 12 is 60. So we know at the 60th period, he's going to throw $5,000 in there. So there's our cash flow. He's going to start putting money in next month, put money in every month for 10 years. But in year 5, period 60, boom, he's going to put $5,000 in. So what is his A? Well, there's all sorts of ways to do this. Okay, so let's look at method number 1. The first method. I'm going to take all my money to the future and solve for A. Okay, so the future would be my A brought to the future plus that $5,000 in period 60 brought to the future. Well, if I think of this $5,000 right here, if I think of this $5,000 and this $20,000 up here, that sure looks to me that this looks like a P compared to this future. So if I wanted to draw my cash flow, I could break it down. I could say, well, it's 1 through 60 of my A plus, I'm sorry, 1 through 120, sorry, 1 through 120 plus 160, 120. I've got 5,000. F equals 20. I mean, that's got to be brought up, and that's got to be brought up, and both of those brought up equal 20,000. The A brought up to 120 plus this 5,000 brought up. So I know that my $20,000, which is in year period 120, is going to be my A, find a future given an A at 0.25% for 120 plus 5,000, find a future given a present, right? This is a present, this is in the future. What would that N be? Well, A is still going to be 0.25%. How long are we going to let it hang out there? Well, period 60 to period 120 is 60 periods. So I know that $20,000 has to equal that A brought up to period 120 plus the 5,000. So I'll look in the back of my book, and I'm going to get A times 139.743 plus 5,000 times 1.162. Well, I multiply 5,000, take it off 20,000, then divide both sides by 139.74. Just solve for A. It's just a little algebra equation. 101.54. So I'm going to take all of my money to the future. That's one way to solve it. Another way to solve it, I'm going to do it over, I'll do it right here. Number 2 is instead of taking all the money to the future, I'm going to take all the money to the present, or period 0. Now, I don't know why I'd really want to do this, because that means I got to move everything. Okay, so then I've got to remember the money I want out has to equal the money I put in, right? So money in equals money out because of equivalence at year 0. So the money I'm going to take out, well, we'll do in. The money I'm going to put in is my A, okay? And I would bring that A back, P given A, I for 120. Plus, I've got that 5,000, that's a future, P given F, I 60. Has to equal the money I'm going to take out, that's a future, P given F, I 120. Now you say, well, how'd you do that? Well, just think of it as a puzzle again, right? We're at year 0. We have an A running from year 1 to 120. I got to bring it back to year 0. I'm going to add to it period 0, period 60, that 5,000. I got to get that back to period 0. And that's my money in. That has to equal the 20,000 I've got out here in period 120 back to year 0. Because I only can add the numbers when they're on top of each other in the same period, right? I can't add the 5,000. I can't just say 20,000 in period 120, take off 5,000 in period 60. No, because I'm earning interest. The 5,000 in period 60 is worth a lot more than 5,000 once it sits in there and earns interest. So here I just moved everything back to 0. Notice I had to look up 3 factors. So that's probably not a good way to do it, but I wanted to show you that that's an option. Where's my pen? I've lost my pen. Okay, I don't know what's going on. Oh, there it is, sorry. So I'm going to come over here, I'm going to fill that in. So I'm going to do A times P given A 120 my I is 0.25 and 120, it's 103.563. 103.563. You can look that up in the book. Plus 5,000. P given F I 60. 0.8609 equals 20,000 times 0.7411. Another algebra. Do my math. I get 101.56. Same answer. Option number 2. Well, we can do one other way. Let me see what, I don't like to do anything longer than 8 minutes. Let's see where I'm at. Oh, I'm at 10 already. Okay, the other way, I'm just going to write down the equation. I'm going to turn everything into A. Okay, so money in is equal to money out. So I've got money in is A, plus I've got to take my 5,000. I can't turn that into an A because it's smack dab in the middle, so I'm going to bring it back to year 0. Find a P given an F, 0.25% for 60 periods. Now it's sitting at year 0. Now I'm going to multiply that guy times find an A given a P, 0.25% for 120. Now what I've done is I spread this over 120 periods. Now my A is at 120 and this is at 120 is equal to 20,000 times find an A given an F, 0.25, 120. Do the math, do the algebra, look up the factors, go ahead, check me. It's 101.62. All the same answer. They're just off because of the way the sig figs are in the table. Lots of ways to solve a problem. If you understand all 3 methods, you are perfect. You are right where you need to be. If you don't, go back through, watch this again, read the book, watch it again, read the lecture notes.